Welcome to Land Navigation for Search and Rescue. This video is part of a series designed to assist SAR volunteers in acquiring skills essential for safe, effective land navigation in a search and rescue environment. The videos for map reading, compass work, and GPS operation are designed to address Washington State's land navigation core competency requirements for ground searchers. The direction between any 2 points is defined in terms of a straight line between the 2 points. The direction is directional, that is, it is from A to B. To measure the direction between 2 points, we must first establish a north reference, then measure the horizontal clockwise angle from the north reference to the line between the 2 points. The direction from A to B is a true azimuth of 60 degrees. It's a true azimuth because we measure and use the horizontal clockwise angle measured from true north. For search and rescue, all directions should be expressed using the clockwise angle from true north. The direction from base camp to the river crossing is 60 degrees. SAR compasses should be declinated. Azimuth is the technically correct term. However, I am finding that many in the search and rescue community use bearing instead. The bearing to your checkpoint is 47 degrees. For this video series, let's define bearing equal azimuth equals direction. And you can choose which term works best for you in your SAR community. For USGS 7.5-minute topographic maps, true north-south and east-west reference lines are the edges of the map, interior latitude and longitude lines, and in most cases, township and range lines. What is the direction from Climber's Bivouac to Butte Camp Dome? First, draw in the line between the 2 points. Establish the true north reference. Determine the clockwise angle from the true north reference. In this case, it's easier to measure the smaller angle and subtract it from 360 degrees, which gives us a true azimuth of 306 degrees. The direction from the bivouac to the dome is 306 degrees. Relatively small errors in direction can create large errors in the field. For increased accuracy, a protractor should be used to measure or plot directions. But don't forget to estimate the direction and use your estimate to guard against errors. When you use a protractor, make sure it's aligned properly. Check to see if you're using the right scale. Remember, you are measuring a clockwise angle from north. Always make an estimate of the direction as an error check. A compass needle points to magnetic north. The angle between magnetic north and true north is known as the magnetic declination. The declination diagram shows 3 north references: true north, grid north, and magnetic north. Magnetic declination changes with time and place. The declination diagram on your map shows the declination at the time the map was made. Be sure to use the current declination for your search area. Magnetic azimuth is the horizontal clockwise angle from magnetic north to the line between 2 points. To measure magnetic azimuth, first plot true north. Then use the magnetic declination to plot the magnetic north arrow. Measure the angle from magnetic north to the line. In this case, the magnetic azimuth is 34 degrees. Magnetic azimuth and true azimuth. In areas where the magnetic declination is to the east, the true azimuth can be obtained by adding magnetic declination to the magnetic azimuth. Magnetic declination is 16 degrees. The magnetic azimuth is 34 degrees. And the true azimuth is 34 plus 16 equals 50 degrees. You can convert in the opposite direction. Magnetic azimuth equals true azimuth minus the magnetic declination. Plotting a known direction on your map. First, establish a true north reference line. Then use a protractor to plot the desired angle, and then draw in the line. If the azimuth from point A to point B is 315 degrees, then the azimuth from point B to point A is called the back azimuth and is exactly 180 degrees opposite of the azimuth. When the azimuth is greater than 180 degrees, you subtract 180 to get the back azimuth. When the azimuth is less than 180 degrees, you add 180 to get the back azimuth. Plotting the back azimuth from a known map feature, such as a mountaintop or a radio tower light, can be useful in finding and describing your location.